Let's see the remaining questions of spheres. So question number 1 for today is, we're supposed to prove that every sphere which is passing through this circle cuts orthogonally every sphere which is passing through this circle. So basically they have given us equation of two spheres and we are supposed to prove that they have given us basically a equation of two circles, and we are supposed to prove that every circle which is every sphere which is passing through these circles cut each other orthogonally. So the equation of circle 1 they have given is x square plus y square minus 2ax plus r square equals to 0 comma z equals to 0. So this is my equation of circle 1, and my equation of circle 2 is x square plus z square equals to r square comma y equals to 0. So since they have given me equation of circle, from here I can find out my equation of arbitrary sphere which is passing through this circle. So equation of sphere passing via circle C1 will be x square plus y square plus z square minus 2ax plus lambda 1z plus r square equals to 0. I can write it because my z is equals to 0, so this is the equation of sphere passing via circle C1. Likewise, I can write equation of sphere passing via circle C2, that will be x square plus y square plus z square plus lambda 2y equals to r square. So this is my equation of circle 1. Let me name it as 1 and this is 2. So they have given me that these two spheres cut each other orthogonally. So if two spheres cut each other orthogonally, then we have result that radius of one square plus radius of second sphere square must be equals to square of distance between their center. So let us find out center and radius of sphere 1. So let C1 be the center of sphere 1. So its center will be a comma 0 comma minus lambda 1 by 2, and its radius, let it be r1, will be a square plus lambda 1 square by 4 minus r square. Likewise, I can find center of sphere C2. It will be 0 comma minus lambda 2 by 2 comma 0, and radius r2 will be under root lambda 2 square by 4 plus r square. So now using the orthogonality result, I'll get a square plus lambda 1 square by 4 minus r square plus lambda 2 square by 4 plus r square is equal to a minus 0 whole square plus 0 minus lambda 2 by 2 whole square plus minus lambda 1 by 2 square. So if I simplify it, I will get a square plus lambda 1 square by 4 plus lambda 2 square by 4 is equals to a square plus lambda 2 square by 4 plus lambda 1 square by 4. So my RHS and LHS are both equal, so the condition of orthogonality is satisfied. So any arbitrary sphere passing via the given circles are orthogonal to each other. So we can say that spheres S1 and S2 cuts each other orthogonally. So let's move on to next question. So the next question says that a moving plane passes via a fixed point. So let's say P be my fixed point 2, 2, and my moving plane be, let plane be x by a plus y by b plus z by c equals to 1. Let this be my moving plane and let me name this as equation number 1. So it is given that this equation of plane passes via point P. So if it is passing via point P, then 2 by a plus 2 by b plus 2 by c must be equals to 1. Let me name this as equation 2. Further, it says that this moving plane meets the coordinate axis at point A, B, C. So plane 1 meets coordinate axis at A, B and C. So I can calculate coordinates of A, B and C. So my A will be A, 0, 0. Likewise my B will be 0, B, 0. And my C will be 0, 0, C. And all away from origin. These points are away from origin. Further, it have asked me to find the locus of center of sphere passing via point OABC. So now I am supposed to find sphere via OABC. So let us assume any arbitrary equation of sphere, that will be x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equals to 0. So from here I'll get my d equals to 0. A square plus 2ua equals to 0. B square plus 2vb equals to 0. And c square plus 2wc equals to 0. So if I calculate, I'll get my u as minus a by 2, v as minus b by 2, and w as minus c by 2. So I got my equation of sphere passing via OABC. So my equation of sphere is x square plus y square plus z square minus ax minus by minus cz equals to 0. Further, I can just find center of the sphere because I am supposed to locate the center. So center of my sphere passing via O, A, B and C point will be minus u minus v minus w. That is basically a by 2, b by 2, c by 2. So now let us assume let x, y, z be locus of sphere. Then my x must be equals to a by 2, y must be equals to b by 2, and z must be equals to c by 2. No, I guess there is no need to do this. I can just find out value of a, b and c. So if I compare, I got my a as minus 2u, my b as minus 2v and my c as minus 2w. And if you remember that we have already find out a equation in a, b and c. So I'll just substitute my value of a, b and c in that equation. So I'll get 2 upon minus 2u plus 2 upon minus 2v plus 2 upon minus 2w equals to 1, where minus u, minus v and minus w are basically a center of sphere. So if I further simplify it, I'll get 1 plus 1 by u plus 1 by v plus 1 by w equals to 0. So this is by locus of center of sphere, where center of my sphere is minus u minus v minus w. So this is the required locus. So I can also write it as 1 upon x plus 1 upon y plus 1 upon z equals to 0. So this is required locus of sphere. So now let's move on to next question. So the next question says that the sphere S has point dash this and this as opposite ends of a diameter. So they have given us two endpoints of a diameter of a sphere. Let us name it as A and B. So AB is diameter of sphere S. So using this diameter we can easily find out equation of sphere S. Further it says that find the equation of sphere having intersection of sphere S with plane this as great circle. So they have given us equation of a plane. Let's say this be my equation of plane. Let this be my plane, and when the plane and sphere intersect, it forms a circle. So if this is the circle, So they have asked us to find the equation of sphere for which this circle formed by intersection of plane and sphere S is a great circle. And this one is a repeated question. We have discussed this same question in previous part of this series. So let us just move on to next question. So the next question says that show that three mutually perpendicular tangent lines can be drawn to this sphere from any point on this sphere. So they have given us two equation of sphere. Let us name it as sphere S1 and sphere S2. So if P is any point on sphere S2, so they have asked us to prove that from any point P we can just draw three mutually perpendicular tangent lines on this sphere. So if I draw three mutually perpendicular tangent lines on this sphere, so this will basically form an enveloping cone of sphere S1 with P as vertex. So first let us find out that equation of enveloping cone of sphere S1 with P as vertex. So equation of sphere S1 is x square plus y square plus z square equals to r square, and equation of sphere S2 is x square plus y square plus z square equals to 3r square by 2. And let P be any point alpha, beta, gamma on a sphere S2. So equation of enveloping cone of sphere S1 with P as vertex, P alpha, beta, gamma as vertex will be S1 equals to T square. So where T is basically tangent and S is the sphere S1, and basically let's name it as sphere S2 S dash, as it's creating confusion. And S dash is basically when the point alpha, beta, gamma satisfies equation of sphere S1. So that is equals to x square plus y square plus z square minus r square into alpha square plus beta square plus gamma square minus r square equals to alpha x plus beta y plus gamma z minus r square whole square. So this is basically the equation of enveloping cone of sphere S1 with P as vertex. Also notice that P has three mutually perpendicular and tangent to the sphere. So these three lines, mutually perpendicular lines, are basically generators of this enveloping cone. So there are three mutually perpendicular generators to enveloping cone, and we know that these three mutually perpendicular generators to enveloping cone are possible if and only if sum of coefficient of x square, y square and z square is equals to 0. So we are supposed to verify that sum of coefficient of x square, y square, z square equals to 0. Only then these 3 points will be basically mutually perpendicular tangent lines to sphere S2. So coefficient of x square, if we compare, is alpha square plus beta square plus gamma square minus r square minus alpha square. We can just, from here, my coefficient of x square is this, and alpha square will be coefficient on right hand side, and if we take it on left hand side, we'll get this as coefficient of x square. Likewise, coefficient of y square is alpha square plus beta square plus gamma square minus r square minus beta square, plus coefficient of z square is alpha square plus beta square plus gamma square minus r square minus gamma square. So we are supposed to prove it equals to 0. So this is basically equals to, if we simplify it, we'll get this alpha square balances out this one, beta square balances out this one, likewise gamma square balances out this one. So we are left with 2 into alpha square plus beta square plus gamma square minus 3 r square. But since this point P is lying on sphere S2, P is on sphere S2, so point P must satisfy equation of sphere S2. So from there I'll get alpha square plus beta square plus gamma square equals to 3r square by 2. So using this relation in this equation, I'll get 2 into 3r square by 2 minus 3r square, which is basically equals to 3r square minus 3r square, which is equivalent to 0. So I can say that three mutually perpendicular tangent lines can be drawn from any arbitrary point on this sphere S2 to sphere S1. Let's move on to next question. So next question is, show that all the sphere that can be drawn through the origin and each set of point where the planes parallel to this cuts the coordinate axis form a system of sphere which are orthogonal to this sphere. So the question is saying that they have given us two equation of sphere. Let sphere S1 be this sphere, which is x square plus y square plus 2fx plus 2gy plus 2hz equals to 0. Let us name it as 1. And sphere S2 is basically equation of sphere which is passing via point O, A, B and C, where A, B, C are basically points on coordinate axis where plane parallel to x by A plus y by B plus z by C equals to 0 cuts them. Where any plane parallel to this cuts coordinate axis. So any plane parallel to this plane would be x by A plus y by B plus z by C equals to k. So and this plane will cut coordinate axis at point, let's say A. So A will be AK, 0, 0. B will be 0, BK, 0. And point C will be 0, 0, CK. So the question says that we have to prove that sphere S1 and sphere S2, which is basically passing via O, A, B, C, cuts each other orthogonally if this condition holds. So let us first find out equation of sphere S2. Equation of sphere via O, A, B and C will be, let us assume any arbitrary equation of sphere, that will be 2ux plus 2vy plus 2wz plus d equals to 0. So if I put value of A, B, C and O here, I'll get my d as 0. A square k square plus 2u ak equals to 0, a square k square plus 2b square bk equals to 0, and c square k square plus 2w ck equals to 0. So from here I can find out value of 2u. So my 2u is basically minus of ak equals to 2u. Likewise my 2v is minus of bk and my 2w is minus of ck. Also any sphere passing via point O, A, B and C, like points similar to this, you can easily find out without writing this, because like similar sphere we are supposed to find in every other question, so you'll get used to it. You can write directly as well. So my equation of sphere is x square plus y square plus z square minus akx minus bky minus ckz equals to 0. So this is my sphere S2. Let's name it as S2. So we are supposed to prove that S1 and S2 cuts orthogonally if this relation holds. So let us find out center and radius of both the spheres. So let C2 be center of sphere S2. That will be AK by 2, comma BK by 2, comma CK by 2, and radius, let's say R2. So radius will be basically a square k square by 4 plus b square k square by 4 plus c square k square by 4. Likewise, we can find a center C1 of sphere S1. That will be basically minus f minus g minus h, minus f minus g minus h, and radius R1 will be basically f square plus g square plus h square, because constant term is also not there in sphere S1. So since we have center of both the spheres and radius of both the spheres, so using orthogonality condition of two spheres, I'll get R1 square plus R2 square equals to C1 C2 square. So if I substitute values here, I'll get R1 square as f square plus g square plus h square, R2 square as a square k square by 4 plus b square k square by 4 plus c square k square by 4, which is equals to, since I have coordinates of C1 and C2, I can just find distance between C1 C2 using distance formula. That will be AK by 2 plus f square plus bk by 2 plus g square plus ck by 2 plus h square. So if I just simplify this equation on right hand side, I'll get left hand side is same only, this one only. So if I simplify on right hand side, I'll get a square by k square by 4 plus f square plus a kf plus b square k square by 4 plus g square plus b kg plus c square k square by 4 plus h square plus ckh. So if I see that this term balances out the one on left hand side, likewise this one balances out this one, c square k square by 4 balances this, likewise we can balance out f square, g square and h square. So we are left with akf plus bkg plus ckh equals to 0, which is also equivalent to af plus bg plus ch equals to 0. So this is my condition for the sphere S1 and S2 be orthogonal to each other, and this is the exact same condition which we are supposed to prove. So let's move on to next question. So the next question says that show that the equation of sphere which touches this sphere at point this and passes through this is this. So let's say this is my sphere S1 and this is my sphere S2. Sphere S1 and S2 touch each other at point, let's say P. So my point P is 1, 2, minus 2. So the question says that show that the equation of sphere which touches this sphere at this point and passes through this point, it is passing via minus 1, 0, 0 is this. So in question they have given me equation of one sphere. Let this one be S1. So S1 is x square plus y square plus z square plus 10x minus 25y minus 2z equals to 0. So if I simplify it, I will get x square plus y square plus z square plus 10 by 4, which is 5 by 2x minus 25 by 4y minus z by 2 equals to 0. So this is the equation of sphere, and it is saying that we are supposed to find equation of sphere S2 which is touching sphere S1 at point P, and also sphere S2 is passing via -1, 0, 0. So let's say C1 be my center of sphere S1 and C2 be my center of sphere S2. I can easily draw a line in between center of sphere S1 and S2. Also, you must observe that this line will also be passing via point P. So since I have my point P as 1, 2, -2, and also I can find coordinates of sphere center of sphere S1, that will be basically -5/4, 25/8, 1/4. So I can easily find out equation of any line passing via a center C1 and C2. So equation of any line via C1, C2 and P will be x minus 1 upon 1 plus 5/4 equals to y minus 2 upon 2 minus 25/8 equals to z plus 2 upon -2 minus 1/4. So if I simplify it, I'll get x minus 1 upon 9/4 equals to y minus 2 upon 16 minus 25 minus 9/8 equals to z plus 2 upon minus 9/4, which I can also simplify as x minus 1 upon 1 equals to y minus 2 upon minus 1/2. Let's just divide by 9/8. I'll get here 2 minus 1 equals to z plus 2 upon -2. So since my equation of line is in symmetrical form, I can easily find out any arbitrary point lying on this line. So any arbitrary point on it will be, let's name it as, let's say it is capital X. So it will be 2r plus 1 minus r plus 2 minus 2r minus 2. So this is my line passing via C1, C2 and P. So any arbitrary point will be of this form. So my center C2 will also be of this form. So my center C2 will be C2r plus 1 minus r plus 2, minus 2r minus 2. So this is basically my center of sphere S2. So since I got a center of sphere S2, so using this, I can find equation of sphere S2, which will be x square plus y square plus z square minus 2 into 2r plus 1x minus 2 into minus r plus 2y minus 2 into minus 2r minus 2z plus d equals to 0. So this is my equation of sphere S2. Further, this equation of sphere S2 is passing via point this -1, 0, 0 and point P 1, 1, 2. So let's name it as star. So star is passing via point P, which is basically 1, 2, -2, and point Q, which is -1, 0, 0. So using these two, we can find basically value of r and d. So that will be 1 minus 2 into 2r plus 1 plus d equals to 0. So from here I got my d as -1 plus 4r plus 2. So d is basically 1 plus 4r. So d is 1 plus 4r, 1 minus 4r minus 2. Yeah. Also it is passing via this 1, 2, -2. So from here I get 1 plus 4 minus 2 into 2r plus 1 minus 2 into minus r plus 2 into 2 plus 2 into 2r plus 2 into minus 2 plus d equals to 0. So if I simplify it, I'll get 4 plus 4 plus 1 9 minus 4r minus 2 plus 2r, it will be 4r plus of 4r minus of 8 minus of 2 to the 4 to the 8r minus 8 plus d, which is basically 1 plus 4r equals to 0. So if I further simplify it, this 4r balances out this one. It is equals to minus 4r plus 9 minus 2 7, 7 minus 8 minus 1, minus 1 plus 1 0, minus 8 equals to 0. So from here I got my r as minus 2. So I can just substitute this value of r here in equation to get my answer. So that is basically equivalent to I guess I have done something wrong. Here my d will be, my x is basically minus 1, so it will be positive. So my d will be, yeah, we have done some calculation mistake. So from here I got my d as minus 2 3 minus 3 minus 4r. So this is my d, and it is also passing via p, which is 1 comma 2 comma minus 2. So if I just put value of this in equation of sphere, I'll get 1 plus 4 plus 4 minus 2r minus 4r plus 2 minus 2 to the 4 into minus r plus 2 and plus 4 into minus 2r minus 2 plus d, which is basically minus 3 minus 4r equals to 0. So if I simplify it, I'll get 9 minus 4r minus 2 plus 4r minus 8 minus 8r minus 8 minus 3 minus 4r equals to 0. So I can just simplify it and see what I get. So I got minus 8 minus this, basically minus 12r, 9 minus 2 7, 7 minus 8 minus 1, minus 1 minus 8 minus 9, and minus 9 minus 3 minus 12, which is equals to 0. So from here I got my r as minus 1. So if I just substitute value of r as minus 1 in star, I'll get my equation of sphere as x square plus y square plus z square minus 2 plus x. So it is 1 minus 2 minus 1, it will be plus 2x, r as minus 1, it is minus 6y, plus my d is minus 3 plus 4, which is basically 1, equals to 0. So my equation of sphere is x square plus y square plus z square plus 2x minus 6y plus 1 equals to 0. So this is my equation of sphere, which is basically touching the given sphere S1 at point P, and the sphere S2 is also passing via point minus 1 comma 0 comma 0. So let's move on to next question. So the next question says that find the point on this sphere that are closest and farthest from point this. So we have done a similar question like this yesterday also. So the equation of given sphere is x square plus y square plus z square equals to 4, and they have given us any point P 3 comma 1 comma minus 1. So let's say this is my equation of sphere S, and let's say this is my point P. So if any line from point P is drawn towards sphere S, let's say this be the line, so it will cut sphere S at 2 points, let's say P and Q. So P will be the nearest point where it will touch sphere S1, and Q will basically be the farthest point where P touches sphere S2. Also this point P passes via center of sphere S. So because then only we'll be able to get the nearest and farthest point, because diameter is basically the greatest largest chord passing via any circle or sphere. So equation also center of my sphere is basically 0, 0. So since I have my point P and point C, I can easily find any equation of line passing via center via C, that is 0, 0, 0, and P, which is basically 3, 1, -1. So equation of my line would be x minus 0 upon 3 equals to y minus 0 upon 1 equals to z minus 0 upon -1. If I equate it with equals to r, then I can easily find any arbitrary point on line, which will be basically 3r, r, minus r. Since this will also be the parametric form of intersection point of line and the sphere, so this point must satisfy equation of sphere S. So using that logic, 3r square plus r square is equals to 4. So from here I got 11r square equals to 4. So value of my r is plus minus 2 by under root 11. So my 2 points where point P is touching a sphere SR, let's name them as P1. That will be basically 3 to the 6 by under root 11, comma 2 by under root 11, comma minus 2 by under root 11. And another one is Q, which is basically minus 6 by under root 11, comma minus 2 by under root 11, comma 2 by under root 11. Now we are supposed to check that which one is farthest and which one is nearest point to the point P. So that we can do using calculating distance between P and P1 and P and Q. So distance P1 would be basically under square. P is my 3, 1, -1. So it would be 3 minus 6 by under root 11 square plus 1 minus 2 by under root 11 square plus minus 1 plus 2 by under root 11 square, and my PQ would be under root 3 plus 6 by under root 11 square plus 1 plus 2 by under root 11 square plus minus 1 minus 2 by under root 11 square. So if you observe that PQ is greater than mod P1, so P1 is nearest point to P and Q is farthest point to P on sphere S1, on sphere S. So this is what we are supposed to do in this question. So the next question is, show that this plane cuts this sphere in a circle of radius 1 and find the equation of sphere which has this circle as great circle. I guess this is also a repeated question. We have done similar question before. So let us see that. So the equation of given plane is equation is x plus y minus 2z equals to 3, and equation of given sphere is, let's name it as S1, that is x square plus y square plus z square minus x plus y equals to 2. So basically this is my equation of sphere and this is my equation of given plane. So we are supposed to show that if this is my sphere, so and the intersection of this sphere and the given plane is basically a circle of radius 1. So if I draw a perpendicular from center of sphere to the equation of plane, then I can easily get this radius r of sphere. Also I can find this perpendicular distance as well. So using that I can easily show that this distance is basically 1. Let's name this point as M and this point as R. So the given equation of sphere is S1. So from here I got my center C1 as 1 by 2 comma minus 1 by 2 comma 0, and my radius R1 as under square 1 by 4 plus 1 by 4 plus 0 minus of minus 2, which is basically equals to 1 by 2 plus 2 to the 4 plus 1 5, which is equals to under root 5 by 2. 5 by 2. Further, I know center of sphere as C1 and I have equation of plane as well, so I can easily find perpendicular distance between C1 and plane. That will be equals to 1 by 2 minus 1 by 2 minus 2 into 0 minus 3 divided by direction cosine, that is basically 1 square plus 1 square plus minus 2 square. So if I simplify it, I'll get this distance as 3 by under root 6. So if I using Pythagoras theorem on triangle CMR, so using that I'll get CM square plus MR square is equals to CR square. So this perpendicular distance is basically my CM, so using that I'll get 3 by under root 6 square plus MR is what I'm supposed to find is equals to CR. CR is basically my radius of given sphere, which is under root 5 by 2. So that is under root 5 by 2 square. So if I simplify it, I'll get 9 by 6 plus MR square equals to 5 by 2. So from here I got my MR square as 5 by 2 minus 3 by 2, which is basically 1. So using this I got my MR as 1. So basically we have proved that the intersection circle formed by intersection of sphere and plane is of radius 1. Further, we are supposed to find the equation of sphere which has this circle as great circle. So we are supposed to find equation of this sphere for which this circle is basically the great circle. Okay, so since I know that I have drawn a perpendicular from this center C to plane M, so I can easily find out equation of this line. So equation of line passing via C and C1 and perpendicular to plane x plus y minus 2z equals to 3. So that will be basically x minus 1 by 2 upon 1 equals to y plus 1 by 2 upon 1 equals to z minus 0 upon minus 2, where 1 and minus 2 is basically direction cosine of normal to the given plane. So I can easily find out any arbitrary point on this equation by equating it with r. So any arbitrary point would be r plus 1 by 2, r minus 1 by 2, minus 2r. So that will also be basically the parametric form of intersection of perpendicular line and the plane. So this is basically point M. So my point M will be of this form in parametric form. Further in question says that this circle serves as great circle to the sphere which we are supposed to find. So if this circle is at the great circle to that sphere, so this point M must act as a center to the sphere. Also this point M is lying on this equation of sphere. So using that I can find out value of this r, which will be basically r plus 1 by 2 plus r minus 1 by 2 minus 2 into minus 2r equals to 3. So if I simplify it, I'll get 2r plus 4r equals to 3. So from here I got my r as 1 by 2. So if my r is 1 by 2, then my point M, which is basically center of required sphere, that would be 1 by 2 plus 1 by 2, 1, comma 0, comma minus 1. So this is basically my center of sphere. Also we know that if this is acting as great circle, so this is basically the greatest circle passing via the sphere which we are supposed to find. So 1 will act as radius of the required sphere. So radius of required sphere is 1 and center is this. So equation of required sphere will be x minus 1 square plus y minus 0 square plus z plus 1 square equals to 1. So this is basically my equation of sphere, for which intersection of given plane and sphere is acting as a great circle. So next question is, show that every sphere through this circle cuts orthogonally every sphere through this circle. So this is the exact same question. This exact same question we have discussed earlier as well. I think this is the first question we discussed today. So let's move on to next question. So the next question is, find the equation of sphere passing through the circle this and touching this. Okay, so the given equation of circle is x square plus y square plus z square minus 6x minus 2z plus 5 equals to 0, comma y equals to 0. So any sphere via this will be of form x square plus y square plus z square minus 6x minus 2z plus y plus 5 plus lambda y equals to 0. So center C of this sphere would be of form 3 comma minus lambda by 2 comma 1, and radius will be basically 9 plus lambda square by 4 plus 1 minus 5, which is basically under root lambda square by 4 plus 5. Further it says that this equation of a sphere is touching the plane P. So my given plane is 3y plus 5z plus 5. So plus 5 equals to 0. So if this plane is touching our sphere star, then my radius must be equals to perpendicular distance from center on this sphere. So my radius, which is basically 5 plus lambda square by 4, must be equals to perpendicular distance between this plane from this point. So I got 3 into minus lambda by 2 plus 5 plus 5, this is 4, plus 4 plus 5 divided by under root 9 plus 16. So if I simplify it, I'll get 5 plus lambda square by 4 under root is equals to minus 3 lambda by 2 plus 9 upon 5. So I can take square of both sides. So using that, I'll get 5 plus lambda square by 4 is equals to 9 minus 3 lambda by 2 divided by 25, which is further equals to 125 plus 25 lambda square by 4 is equals to 9 9 is 81 plus 9 lambda square by 4 minus 27 lambda. And if I just simplify it, I'll get 16 4 lambda square plus 27 lambda plus 125 minus 81, that will be 25 plus 19 44 is equals to 0, which is basically equals to 4 lambda square plus 16 lambda plus 11 lambda plus 44 equals to 0. So if I take 4 lambda common, I'll get lambda plus 4 plus 11 into lambda plus 4 equals to 0, which is basically equals to 4 lambda plus 11 equals to 0. So from here I got my lambda as minus 4 comma minus 11 by 4. So equation of required sphere is x square plus y square plus z square minus 6x minus 4y minus 2z plus 5 equals to 0, and x square plus y square plus z square minus 6x minus 11 by 4y minus 2z plus 5 equals to 0. So there are two such spheres which are basically passing through this circle, and this plane is basically tangent to that sphere. So we are done with this question as well. So let's move on to next question. The next question says that find the equation of sphere having its center on this plane and passing through this circle. So it says that center of sphere lies on 4x minus 5y minus z equals to 0, and sphere is passing via, let sphere be S is passing via x square plus y square plus z square minus 12x minus 3y plus 4z plus 8 equals to 0, and 3x plus 4y plus 3 minus 5z equals to 0. So equation of any arbitrary sphere passing, any arbitrary circle passing, sphere passing via this circle would be x square plus y square plus z square minus 12x minus 3y plus 4z plus 8 plus lambda 3x plus 4y minus 5z plus 3 equals to 0. So if I simplify it, I'll get x square plus y square plus z square plus 3 lambda minus 12x plus 4 lambda minus 3y plus minus 5 lambda plus 4z plus 3 lambda plus 8 equals to 0. So if this is my equation of sphere, I can easily find out center of this sphere. That would be 12 minus 3 lambda by 2 comma 3 minus 4 lambda by 2 comma 5 lambda minus 4 by 2. Also in the question it is given that this center of sphere lies on this plane. So using that I got 4 into 12 minus 3 lambda by 2 minus 5 into 3 minus 4 lambda by 2 minus 5 lambda minus 4 by 2 is equals to 3. So if I simplify it, I'll get 12 4s are 48 minus 12 lambda minus 15 plus 20 lambda minus 5 lambda plus 4 equals to 6. So on further simplifying it, I'll get 20 minus 5 15, 15 minus 12 3 lambda, and 15 plus 4 minus 11, 48 minus 11 is basically 37 minus 6 equals to 0. So from here I got my lambda is minus 31 by 3. So if my lambda is minus 31 by 3, so equation of required sphere is x square plus y square plus z square minus 12x minus 3y plus 4z plus 8 minus 31 by 3, 3x plus 4y minus 5z plus 3 equals to 0. So this is basically my required equation of sphere. You can also simplify it further, but that is just the calculation part. There is no explanation involved in that. So you can do that yourself. So let's move on to next question. So the next question says that show that this plane x plus 2y minus 4z cut this sphere in a circle of radius unity, and find the equation of sphere which has this circle as one of its great circles. This is a basically repeated question. We have done this question previously. So let's move on to next question. So next question says that obtain the equation of plane which passes through point this and touch the sphere this and are parallel to this line. Okay, so my given sphere is, let's name it as S1, and that is x square plus y square plus z square equals to 9. Given equation of line, let's name it as L1 is x by 2 equals to y by 1 equals to z by minus 2, and given point, let's say it is P 3, 0, 3. So we are supposed to find equation of plane which passes through this point. So equation of plane must pass through point P, and that plane is touching the sphere, given sphere. Also that plane is parallel to the given line. So equation of any line passing via point P, that is 3, 0, 3, and parallel to line L1 would be x minus 3 upon 2 equals to y minus 0 upon 1 equals to z minus 3 upon minus 2. So I can write this equation in unsymmetrical form or general form. That would be x minus 2y minus 3 equals to 0 is equal to z plus 2y minus 3. So this is my equation of line which is passing by a given point P and which is parallel to line L1. So equation of any plane, let's name this line as L2. So equation of any plane passing via L2 would be x minus 2y minus 3 plus lambda into z plus 2y minus 3 is equals to 0. So if I simplify it, I'll get x plus 2 lambda minus 2 into y plus z lambda z minus 3 lambda equals to 0. So this is basically my required equation of plane. So in question it further says that this equation of plane is basically touching the given sphere. So if this sphere equation of plane is touching the given sphere, then this must act as tangent to sphere S1. So let's name it as star. So star is basically tangent to sphere S1. So if this is tangent to sphere S1, then radius of sphere S1 must be equals to perpendicular distance from center of sphere to this plane. So using that, my center of given sphere is basically 0, 0, 0, and radius is 3. So using that, I got my 3 as equivalent to minus 3 lambda upon under root 1 plus 2 lambda minus 2 square plus lambda square. So if I simplify it, I will get 1 plus 2 lambda minus 2 square plus lambda is equals to 1 plus lambda square. So if I simplify it, I'll get 1 plus 4 lambda square plus 4 minus 2 to the 4 to the 8 lambda plus lambda square equals to 1 plus lambda square plus 2 lambda. So I can just simplify it. I will get 4 lambda square minus 10 lambda plus 4 equals to 0. So from here I got my lambda as Yeah, lambda is 10 plus minus under root b square minus 4 into 4 upon 8, which is basically equals to 10 plus minus 4 4 is 16, 4 is 64, and 100 minus 64 is 36, and under root of that is 6 by 8, so it is basically 16 by 8 or 4 by 8. So my lambda is basically 2 or 1 by 2. So my required equation of plane are x plus x minus 2y minus 3, x minus 2y minus 3 plus 2 into z plus 2y minus 3. Z plus 2y minus 3 equals to 0 when my lambda is equals to 2, and x minus 2y minus 3 plus 1 by 2 into z plus 2y minus 3 equals to 0 when my lambda is 1 by 2. So there are two such equation of planes which are basically a tangent to sphere S1 and passing via point 3, 0, 3 and parallel to given line L1. So these are the required equation of plane. So let's move on to next question. So the next question is, find the equation of the tangent line to this sphere at this point. So equation of any, we are supposed to find equation at point minus 3, 5, 4 and equation of circle, find the equation of in symmetrical form. So tangent line, it is tangent line, not tangent plane. So we are supposed to find equation of line which is tangent to given sphere and passing via this point. Okay, so given equation of circle is x square plus y square plus z square plus 5x minus 7y plus 2z minus 8 equals to 0, and 3x minus 2y plus 4z plus 3 equals to 0. Okay, so first let us find out. So let's find out equation of tangent plane to sphere at minus 3, 5, 4. So that would be basically minus 3x plus 5y plus 4z plus 5 by 2 into x minus 3 minus 7 by 2 into y plus 5 plus 2 by 2 into z plus 4 minus 8 equals to 0. So if I simplify it, I will get minus 3x plus 5x by 2 plus 5y minus 7y by 2 plus 4z plus z minus 5 3s are 15 by 2 minus 7 5s are 35 by 2 plus 4 minus 8 equals to 0. So if I further simplify it, I'll get minus x by 2 plus 3y by 2 plus 5z, it will be minus 4 minus 35 40 50 by 2 minus 25, that is basically 29. So on further simplifying it, I'll get x minus 3y minus 10z minus 10z plus 58 equals to 0. So this is basically my equation of tangent plane to sphere. So if this is my sphere and this is my equation of tangent plane, so we are basically supposed to at point P minus 3, 5, 4, and this is equation of circle that is given to us. So we are basically supposed to find the equation of tangent line. So if L comma M comma N are basically direction ratios of equation of tangent line at this plane, then that tangent line must pass through this plane as well. So, and here 1, -3 and -10 are basically direction cosines of normal to the tangent plane. So using that, I got L minus 3m minus 10n equals to 0. Further, since I'm supposed to find a tangent line to this equation of circle, so L comma M comma equation of line with direction cosines proportional to L comma M comma N must be perpendicular to equation of line with direction cosines proportional to 3 comma minus 2 comma 4. So using that, I got 3L minus 2M plus 4N equals to 0, and I can solve these two equations using a cross multiplication method. By that, I'll get minus 12 plus minus 20 equals to minus M upon 4 plus 30 equals to N upon minus 2 plus 9. So if I simplify it, I'll get L by minus 32 equals to M by minus 34 equals to N by 7. So my direction cosine of required line are proportional to this, and my line is passing via point P, which is basically minus 3 comma 5 comma 4. So equation of tangent line to given sphere, so it is basically x plus 3 by minus 32 equals to y minus 5 by minus 34 equals to z minus 4 by 7. So this is my required equation of line, tangent line to the given sphere. So the next question is, the sphere S has point this and this as opposite ends of diameter. So if this is my sphere and A and B are basically opposite ends of diameter, so using this I can find equation of sphere. Further, it says that find the equation of sphere having intersection of sphere S with this plane as great circle. So if this is my given plane, so I am supposed to find equation of a sphere for which this circle formed by intersection of plane and this given sphere act as great circle. So I am supposed to find equation of this sphere. This is a repeated question. We have done a similar question before. So let's move on to next question. So the next question is, obtain the equation of sphere that touches the plane this at point this and cuts orthogonally this sphere. So we are supposed to find equation of sphere. If this is my required equation of sphere and this is equation of given plane, so if this is my plane, so the plane touches the sphere at point P, that is 1 comma minus 2 comma 1. Further, it says that this sphere is basically orthogonal to this given sphere. Let's name it as S dash, and this is S. So we are supposed to find equation of sphere S, where equation of sphere S has tangent as 3x plus 2y minus z plus 2 at point 1 comma minus comma 1, and sphere S dash is basically orthogonal to sphere S. So what we can do is, we can, this is a repeated question, so what we can do is, let's, if C is my center of this equation and C dash is my center of this equation, so these two circles cut each other orthogonally. Since equation of sphere S dash is already given to me, so I can just find out a center and radius of this sphere. Likewise, I can just draw a equation, take equation of line which is basically passing via this point and then that any arbitrary point on that line would be basically my center, and using that I can find out arbitrary equation of sphere, and using that I can calculate the center of this sphere and this radius as well, and then I can use the orthogonality condition of the spheres, which is basically if this is my r1, this is my r2, then that would be r1 square plus r2 square is equals to c dash square. So using that we can find the equation of required sphere. So that's all I guess. Yeah, so thank you for watching.